Okay, here's my peak reading load cell. It's not beautiful, but we'll see if it works here in a minute. This is a check valve. Fluid can only go in that direction. And so when we apply force to the piston here, we should get some fluid go to the gauge. It's a 0 to 1000 psi gauge. And when the pressure or force on the piston is released, the gauge should stay at the reading. And then when this valve is cracked open, the reading should go down to 0. Now the load cell is built around a short body ram. I got this at Harbor Freight, and it comes with a fitting so it can be hooked up to a hand pump. And this fitting was removed in order to put this other stuff there. So what I did was clamp this in a vise this way so the piston could come out. And after removing the fitting, I took a syringe and sucked up some hydraulic jack oil into it, and then put it up against the hole and squirted the oil in. And this made the piston come out. Then I attached the rest of the stuff and in a vise squeezed the piston to fill everything else with oil. This was before I attached the gauge. And then the gauge was attached. So at that point everything was pretty much filled with oil. So I started by silver soldering some 1/8" stainless steel tubing to these short nipples here. And I made them that long because I wasn't sure I could make them come out in line. And if it didn't come out in line, then I was going to be able to bend the tubing. But as it turns out, I was able to line them up. And this was a needle valve, and this was just a right angle fitting. So this was all silver soldered together. And I know it's crude, but to do it with real fittings, it would have been quite cumbersome. And so this is what I came up with. So let's take it to the vise and see if it actually works. This was my test piece to see how the silver soldering would work. And I used this type of silver solder that has the flux around the silver solder wire. And I soldered it with a normal propane torch. I mean, this is a high BTU torch, but it is just a propane torch. So let's put our finished unit in the vise here. And squeeze it. Okay, there we're about 200 psi. And it stays. And then when we open the valve, it comes down. Now I did see a slight movement there, but it stays long enough that you could take a reading, that's for sure. So I don't know that the check valve is absolutely stopping the reverse flow. Let's try it again. Okay, there's 200. Okay, I could write that down. And you see it is creeping. And then when we open the valve, down she goes. So I think that will be useful for our intended purpose. Well, here's our final assembly. And the hydraulic ram has two mounting holes, and I've mounted it on this plate with the center of the piston lined up with the ram of the hydraulic jack here. Then I've machined a detent in here with a beveled edge, and this is a beveled edge on this piston, so this will fit on there and line up parallel to the other face. So now the question is, will my hydraulic assembly here withstand 1,000 psi? This valve is definitely not rated for that, but it just might be okay. We'll see. So I'll make sure we're closed there. Normally our sample would be in here. I wouldn't have to crank it quite this far. Okay, now we're in contact and we're starting to read. Let's see if things hold together at 1,000 psi. And it looks like they do. So let's see what happens when we release the pressure. Okay, it holds, it's gradually moving, but there's enough time there to capture the reading. Either the bypass valve or the check valve is leaking slightly. But when I open the bypass valve, we go back to 0. So the thing holds together at 1,000 psi. Now I believe the piston in this 10-ton ram is bigger than 1 square inch. And that's what we'll have to calculate next, is the area on this piston to see how much force we get at 1,000 psi. So there's a video of a guy that did something similar with a 20-ton ram, and he actually took it apart and measured the piston diameter. So I think we can use some of what he did to figure out the piston area without tearing this one apart. So let's do that next. There's a video by Garage Geek where he uses a 20-ton version of the hydraulic ram, and he takes it apart and measures the piston diameter, and he measures 2.36 inches, and on his box it said capacity 40,000 pounds, but the same pressure. So what I did was calculate the pressure that's actually required based on the diameter of the piston, and we find that it's really only 9144 psi required. So this 9250 must be like the maximum pressure that they want to apply to the ram. So at any rate, the area of his piston was 4.374 square inches. So I'm assuming in the 10-ton ram that there's one half the area. So the area would be then 2.187 square inches. So at 1,000 psi, now that's as far as I can read on the gauge that I have installed. So the force at 1,000 psi times the area would be 2,187 pounds. So that's the limit that I can test to with the 1,000 psi gauge. Okay, we're back to our testing machine. I put a label on here so I wouldn't forget what the force is per psi. And also I've coated the ends of these pieces with a hard rubber. In actual concrete testing machines, they mold on the ends of the sample either gypsum or molten sulfur to evenly distribute the force on the test piece. Now here's a muffin that was made over 2 months ago. The previous Aircrete video that I did was published over 2 months ago, and these were made at that time. So I don't know if we have enough force to break one of these. Now there's no foam in this. It is only cement, Portland cement, and water mixed at that ratio that everyone seems to use of 94 pounds of cement and 6 gallons of water. So let's see what happens when we put this in the machine and subject it to a little over a ton of force. Well, I see it cracking on the left side. I think maybe you can hear that. So it looks like it just made it. So let's take it out and take a look at it. Yep. Now I don't know at what point that fractured. I think when I heard it. So I probably should have taken the pressure up more slowly. I thought it would just break and crumble away. So let's try another sample, and we'll go up in pressure in a slower manner. Okay, here's another sample. guess I forgot to close the valve down here. I guess we'll listen for cracking. Forgot to close that valve. It looks like that sample made it to the maximum pressure of the machine here. And I guess there's several things we can do. I can either go to a gauge that goes higher. I have a 5,000 pound gauge, but I'm a little worried about the stuff here holding up. Another thing I could do is change this to the 20-ton ram, and that way I would get twice the force at the same pressure. And I guess the third thing I could do is go to mini muffins. And maybe that would be the best thing to do. But I'll think about it and then continue to the video when I make a decision. Now I see the pressure has creeped down a little. Whoops, I went a little too far. But it looks like the sample has held up. So maybe we should check it and see if it has cracked or anything. No, it looks perfectly good. So we got to get our testing working properly before we can go on and actually test samples of Aircrete. Well, I just had a silly idea. This is 1-inch thick styrofoam insulation, and this is a 1 3/4 inch diameter hole saw. So I drilled a hole in the styrofoam, and of course I could drill a bunch of holes in a piece and fill them with various concrete or Aircrete mixtures in order to make samples to test. And I think I could even leave the samples in the styrofoam, because I don't think the styrofoam is going to affect see, if there was concrete in there, we would have to break the concrete before we even start into the foam. But let's see what it takes to crush some foam. Well, here the gauge has not even moved and we're already biting into the foam. I see nothing on the gauge and I don't feel any resistance as I pump, and you can see the foam is severely compressed at this point. So I think the samples, the foam may break off very easily, but if it doesn't, it's not going to affect the results. So with this change in plan, I've got to make up some samples now and age them for approximately a month till they reach full strength. So I'm going to release this video now so you know that I haven't abandoned the project. I have been working on it. And after I've made a bunch of samples and aged them, we'll do another video and see how strong or weak air foam is with various amounts of foam and various other ingredients, perhaps sand and things like that. I'm sure we don't want to use large aggregates. So we'll report back to you in the next video.